So we said in an earlier lesson that in order to move from standard form of a quadratic equation to vertex form, we're going to need to complete the square. The steps are very similar to what you've been practicing in the steps for solving a quadratic equation. Let's take a look at that here. We want to complete the square to find the vertex form of the equation. So the first step when you're given standard form is to bracket the first two terms. Remember, we want 1x squared. And when we don't have 1x squared, we need to divide. I think I've mentioned that you should always line up your equal signs. Remember, we're keeping that -3 here. 18 divided by -3 is -6. We're going to leave some space. Now we want to create a perfect square trinomial inside the brackets. Remember, that was 2 times some number to give us the middle term, and then squaring that number to give us the third term. So here we see that 2 times -3 will give us -6. -3 squared, or +9, creates our perfect square trinomial. This is the step that gets a little difficult. We need to balance the equation. We didn't just add 9 to this equation. We have a -3 times 9. -3 times 9 needs to be balanced with positive 27. -27 plus 27 gives us 0. So now we factor and simplify. Again, keep that -3. Use this -3 to factor. -31 plus 27 is -4. Now we have our vertex form of the equation. Remember, to find the vertex, we use the opposite of the sign beside h, so +3, and we use the sign shown for k. When we're determining whether or not the function opens up or down, we look at a. We see that a is less than 0, and so this is going to open down. We're asking you now to graph this equation. We've changed it to vertex form. Let me write that here. Okay. So we know the vertex. We have that 1 point on the line. We know that it's going to open down. And we need to find one other ordered pair. If I look at the standard form of the equation and I see if I let x equal 0, my y-intercept would be -31. That's an easy point to find, but -31 makes my graph too big. So I'm going to let x equal some other value. How about if we let x equal 1? Let's try that. Remember, x can be any real number. 1 minus 3 is -2. So -3 times 4 is -12 minus 4, -16. Not great, but it will do. So we want to graph this here. I'm going to go by 5s, I think. So my vertex at 3, -4, and another point at 1, oops, I was going by 5s and I put a 16. There we go. 1, -16, about there. Remember, we're going to find another point on the graph using symmetry. I see that the point I found is 2 units over, so I need to go 2 units in the other direction to find my other point on the graph. So the thing we changed from the last lecture is just moving to vertex form. Otherwise, the graphing remains the same. I didn't ask for domain and range here, but let's find it. We see that the domain is the set of all real numbers. Can you pause your video and find the range? Lowest values are at -infinity. The highest value is at my vertex, -4. Here are a whole bunch of questions for us to practice. Why don't we look at doing question 1 together? So part A says that we have to complete the square to find the vertex. Again, if you know the formula, great, but you still need to know this process of completing the square. So let's get started with that. Step 1 says in standard form, bracket the first 2 terms. Well, this only has 2 terms. Can you see which term is missing? Yeah, we could write a +0 here if we wanted to. We don't need to. The first 2 terms are these terms here. We want 1x squared, so we're going to have to divide by 4 inside the brackets. -8 divided by 4 is -2. Leave some space. Complete a perfect square trinomial. 2 times -1. So here we see that -1 all squared or +1 completes the trinomial. We need to balance our equation. So +4 minus 4 brings us back to the original equation. Now we can factor, keeping that 4, using the -1 to factor. Here's our equation in vertex form. So the vertex then, we use the opposite of the sign beside h, so +1. We use the sign we find beside k. There's our vertex. I didn't ask you to determine whether or not the graph opens up or down, but we see that a is greater than 0, so we know that this graph will open up. I've asked us to find intercepts this time. So let's do that. We found the vertex. Let's start with the y-intercept. We're going to let x equal 0. Well, if I look at the standard equation that we started with, if we let all of those x's equal 0, we see that 0, 0 is our y-intercept. It's also one of the x-intercepts. For our x-intercept, we have to let y equal 0. And then, of course, we would factor that equation. We see that 4x is common. Using the zero factor theorem. We see that 0, 0 is one of our intercepts. We have that already. We also see that 2, 0 is an intercept. So now we actually have 3 points for this graph already. We have 2 intercepts and we have our vertex. We need to graph the equation. Oh, I don't like that line there. Let's move it. So our vertex was at 1, -4. We have a y-intercept at 0, 0. And we have another x-intercept at 2, 0. Label your x-axis and your y-axis. The domain, as always, is the set of all real numbers. And the range, using our lowest value from the vertex, -4 up to +infinity. So we have all of these other equations here for you to practice. Take your time, make sure you can graph each of them, find the vertex by completing the square, and finding the intercepts.